Cascade Microtech is the world leader in advanced wafer probing hardware and software used in the design and manufacture of high-speed integrated circuits and hybrid electronic devices. The broad line of innovative Cascade products improve the efficiency of design and manufacturing and serve to accelerate the evolution of advanced semiconductor processes such as very high-speed silicon and the 3-5 family of materials that includes gallium arsenide. This presentation provides information on the two-port calibration procedures of Cascade Microtech microwave probes. A Hewlett-Packard 8510 microwave vector network analyzer will be used for this program. Calibration with the network analyzer permits the repeatable probe head losses and reflections to be removed from measurements. In a two-port calibration, two probes are calibrated individually with an open circuit, a 50 ohm load, and a short circuit. A transmission calibration with both probes is then done. To calibrate two ground signal ground probes with the Hewlett-Packard 8510 network analyzer, begin by installing the probe arms on the front risers for two-sided probing. Ensure that no dirt is present on the riser top mounting surface or on the probe mounting surfaces. Next, install the ground signal ground probes on the probe arms. Now, connect the semi-rigid cables from the network analyzer's ports 1 and 2 to the probe connectors. Note that semi-rigid cables with low VSWR are recommended. However, other high-quality phase-stable coaxial cables may be used. The calibration drift due to temperature changes can be improved by using Cascade Microtech's match reference plane extender cables. Bias for the RF ports can be supplied through the test set, or external bias T adapters to the probe tips. Bias for the other devices under test can be supplied through DC needle probes or from Cascade Microtech's low impedance bypass probes. To protect the bias supplies and calibration devices, turn off all bias supplies during the following calibration. The next step is to load the calibration kit. The Cascade Microtech calibration kit software is used to load electrical characteristics of the Cascade Microtech impedance standard substrate into the memory of the Hewlett-Packard Network Analyzer 8510. To begin, insert the Cascade Microtech calibration tape into the 8510 tape drive. Then, press the following keys to transfer the ISS definitions into the 8510 internal memory. Tape, load, CalKit. Choose CalKit 1 or 2, depending on where you wish to store this information. Then, press the File 1 key. Now, press the Menu Cal key to verify that the calibration program has been successfully loaded. Look for the RF probe entry on the screen under Cal 1 or Cal 2. Set the network analyzer ramp sweep for an averaging factor of at least 4. Set the step sweep at an averaging factor of 128. Set the start frequency to 45 MHz and the stop frequency at 26.5 GHz. Set the sampled frequency points to 51. The next step is to position the ISS onto the chuck. Be sure to inspect the chuck and the ISS backside for particles that can cause nonplanarity. Then, using wafer tweezers, place the ISS onto the chuck. In a full two-port reflection calibration, each probe is first calibrated separately with the open circuit, a 50 ohm load, and a short circuit. Both probes are then connected to the through connection standard for a transmission calibration. These standards are analogous to the standards used in fixed-load coaxial calibration. To continue, press the Network Analyzer Cal menu key. Then select the Cal 1 RF probe. Next, select the type of calibration to be performed, a full 2-port calibration in this example. Now press the reflection soft key. The menu will ask for the appropriate calibration standards. Use the same 1-port standards for ports 1 and 2 during the calibration. The open circuit standard is created by lifting the probes at least 10 mils into the air. Use the Z lever to raise the probes. With the probes in the air, press the open soft key for the port 1 probe and then for the port 2 probe. The next procedure is the 50 ohm load. Place the port 1 probe on the 50 ohm load located to the left of the impedance standard substrate area marked GSG. The ISS print that accompanies a serial numbered ISS shows which resistors have been trimmed to 1/10% for calibration purposes. Note that if any ISS resistor is overheated, the resistor will change value. With the probe contacting the resistor pads, press the load soft key for the port 1 probe. Next, place the port 2 probe on the 50 ohm load. Then, press the load soft key for the port 2 probe. The next procedure will utilize the short circuit standard. Move the port 1 probe to a short circuit standard. Center the probe contacts at the probe tip front on the short circuit standard so that the probe overlaps the short by 1 mil. Note that consistent probe contact placement on the short circuit is particularly important because the electrical length of the short is a function of overlap. Now press the short soft key for the port 1 probe. Then position the port 2 probe on the short circuit standard and press the short soft key for the port 2 probe. Now, with the open, load, and short calibration completed, press the reflection done soft key. Since isolation is not required, complete the following procedure. Press the isolation soft key. Then press the omit isolation soft key. Then press the isolation done soft key. The next procedure is the transmission calibration. To begin, press the transmission soft key. Now contact both probes simultaneously to an appropriate through connection standard at the right of the impedance standard substrate area marked GSG. Begin by contacting one probe to the standard, allowing 1 mil of the through connection to extend under the probe. Note that an overlap greater than 1 mil will act as an open stub and add parallel capacitance. Now adjust the second probe for 1 mil overlap, resulting in 6 mils between the facing probe tips. The 6 mils distance between probe tips corresponds to approximately 1 picosecond of delay on alumina or gallium arsenide. The 1 picosecond transmission delay is preset in the Cascade Microtech calibration kit. Note that the selected through connection standard should be used for all 4 transmission calibration soft key selections. Now, press the forward transmission through soft key. Then, the forward match through soft key. Then, the reverse transmission through soft key. And the reverse match through soft key. When all measurements are complete, press the Done soft key. Now push the 2-port calibration soft key, then store the calibration in one of the 8 calibration sets. The calibration is now stored. Calibration accuracy should be verified before testing other devices. Routine verification usually consists of measuring an open circuit stub on each port. A 1-port measurement of the longest ISS transmission line is a good verification of each port's reflection calibration. Be sure to overlap the end of the line by 1 mil. When a probe is in contact with one end of an open circuit stub and the other end is open, the measured S11 or S22 reflection coefficient should show the magnitude monotonically decreasing with frequency, and the phase linearly increasing with frequency. Further verification is possible by recontacting the calibration standards. This is an easy method of checking that the network analyzer, cables, and probe heads repeat their measurements. Check each probe on a 50 ohm load standard. The reflection coefficient, S11 or S22, should be no more than minus 30 dB. 40 to 60 dB is typical. The open and short circuit reflection coefficient, S11 or S22, should have a magnitude within plus or minus 0.2 dB of 0 dB. The short circuit phase should be 180 degrees of all frequencies, or a dot on the Smith chart. The open circuit phase should appear to be a small negative length due to the relative offset between the open and short standards. Reconnect both probes individually to the previously used through connection standard. Return loss for S11 and S22 should be less than minus 30 dB. S12 and S21 should be unity magnitude. Recheck the original calibration if any of the preceding recontact checks did not show measurement repeatability. This completes the Cascade Microtech microwave probe calibration presentation. Please use and refer to the instruction manual for specific data, details, and information. The people at Cascade Microtech are dedicated to customer service, application support, and the continued development of tools which contribute to the advancement of high-frequency test and measurement. Their commitment to excellence and responsiveness to customer needs is unparalleled. Cascade Microtech is the world leader in advanced wafer probing hardware and software used in the design and manufacture of high-speed integrated circuits and hybrid electronic devices. The broad line of innovative Cascade products improve the efficiency of design and manufacturing and serve to accelerate the evolution of advanced semiconductor processes such as very high-speed silicon and the 3-5 family of materials that includes gallium arsenide. This presentation provides information on the installation, mechanical operation, and maintenance of Cascade Microtech microwave probes. Probes are mounted and used in 3 different configurations with Cascade Microtech probe stations, autoprober top plates, and probe cards. For this presentation, the Cascade Microtech Model 42 microwave probe station will be used. The first procedure is to mount the probe arms and probe heads. Prior to mounting the arms, check the mounting surfaces for burrs or dirt. Next, position the arm on the riser and snug tighten the 3 screws that hold the arm to the riser. Prior to mounting the probes, be sure that the Z-lever is up and the wafer stage is positioned to the front of the grease plate to provide clearance between the probes and the wafer stage. Remove the probes from the storage cabinet, grasping the probe head block by using a thumb and forefinger, pulling straight up. Next, position the probe over the arm and lower over the arm's locator pin. Then, snug tighten the 2 mounting screws. Before repositioning the wafer stage under the probes, visually verify that there's adequate clearance. It's also recommended that the probes be stored in their cabinet when not in use. Prior to beginning the next phase, over travel adjustment, please note that there is risk of damaging microwave probes if the Z-lever is up when adjusting the Z-axis micrometer heads for contact to the device under test. With the probes already contacting the device, moving the Z-lever down can damage the probes. Over travel is the continued downward vertical movement of the probe after initial contact with the device's contact pads. It's important that you always observe through the microscope the probe tips when positioning them. The probe tips will appear out of focus when the microscope is focused on the device under test, and the probe tips are safely raised. First, use the X and Y axis micrometer heads to position the probe tip contacts above the device's contact pads. Now, carefully lower the Z lever. Note that with the Z lever in the down position, the probe tips should not be making actual contact with the pads. With the Z lever in the down position, use the Z-axis micrometer head thimbles to adjust the probe tips to the point of initial contact. At this point, over-travel begins with the continued downward adjustment of the probes. Note that assured electrical contact from most probes can be obtained with 4 mils of over-travel. The adjustment for 4 mils, 4 1/1000ths of an inch over-travel, can be made directly on a Cascade microtech probe station or autoprober by adjusting the Z-axis micrometer head thimbles an additional 4 graduations after initial contact. Each thimble graduation corresponds to 1 mil of over-travel. Microwave probes have a 5-to-1 slope to the device. 4 mils of over-travel produces a horizontal tip movement of 0.8 of a mil. The probe tip horizontal movement is referred to as skating, which can be clearly seen through the microscope if the device is held by vacuum. With experience, the setting of probe over-travel may be done visually using the skating movement as a reference rather than making precise graduated adjustments on the Z-axis micrometer head thimbles. Note that this technique should only be utilized by experienced operators. Keep in mind that assured electrical contact for most probes can be obtained with 4 mils of over-travel, which results in 0.8 of a mil of skating. Note that some multi-contact probes can require up to 8 mils of over-travel to provide assured contact. 8 mils of over-travel produces 1 6/10 mils of skating. Over-travel of 10 mils or less is recommended as a working maximum. Over-travel that exceeds 10 mils can cause damage to probes and to the device under test. The next procedure, probing without vacuum, is recommended to lessen the wear on often used devices such as the impedance standard substrate. Without vacuum hold down, the probe tip moves the device under test rather than skating on the surface. The combined horizontal movement is more difficult to measure than when only the probe tip movement is seen. Therefore, probing without a vacuum should only be done by experienced operators. Use caution when probing on uneven surfaces. If contact is not made within 10 mils of over-travel, it's important to investigate and correct the cause. Probe damage can occur when a thin device and a thick device are both left on the chuck during probing. Attempting to make contact with a thin device by positioning the probe so that it is reaching over a thick device can cause excessive over-travel and provide limited or no contact with the device under test. Always observe through the microscope the probe tips when positioning them onto the device under test. Make sure to first visually observe and confirm that the proper contact and resulting skating has been made, and then look for an electrical readout. Using a possibly erroneous electrical readout as the only contact verification can lead to excessive over-travel and possible probe damage. Probe crashes should be prevented. Be careful when setting 2 opposing probes down on a through standard or other device that the resulting skating movement does not cause the probe tips to collide or crash into each other. To verify that all probes are making contact, use the supplied substrate. Contact is evidenced by a slight indentation in the gold. The marks may be faint, but as long as they're visible, contact is indicated. Note that the appearance of the individual probe marks will vary. This is normal. If there's a questionable contact, an electrical analysis of continuity may be required. Consult the troubleshooting guide of your manual for detailed information. It's recommended that all probe connectors be checked at frequent intervals as they will wear with use. Prior to making a connection at the probe heads, assure that the probes are not in contact with the device and that they're positioned safely apart. When making a connection, verify that the male and female connectors are properly aligned to avoid cross-threading or damage to the pin. Use a torque wrench to assure repeatability in the connection tightness and to guard against excessive force which can result in damage to the probe tips. Probe tip cleaning may be required periodically. A buildup of dirt can cause the probe tips to lose contact. Prior to cleaning the probe tips, look for other sources of dirt-caused problems. Check the riser, arm, and probe mounting surfaces for dirt or burrs. Clean the wafer stage chuck and clean the wafer. Try cleaning the probe tips with pressurized air before using a solvent. Be sure to blow from the body toward the tip. Isopropyl alcohol is an approved solvent for cleaning probe tips. Use a small amount on a foam-tipped swab. Move the swab from the body to the tip, taking care that the tip is not snagged or pulled up. An ultrasonic cleaner may also be used to clean probe tips. Use clean isopropyl alcohol and immerse the tips only. Be sure to allow sufficient time for the probe tips to completely dry before placing them back into use. This completes the microwave probe installation and care presentation. Please use and refer to the instruction manual for specific data, details, and information. The people at Cascade Microtech are dedicated to customer service, application support, and the continued development of tools which contribute to the advancement of high-frequency test and measurement. Their commitment to excellence and responsiveness to customer needs is unparalleled. Cascade Microtech is the world leader in advanced wafer probing hardware and software used in the design and manufacture of high-speed integrated circuits and hybrid electronic devices. The broad line of innovative Cascade products improve the efficiency of design and manufacturing and serve to accelerate the evolution of advanced semiconductor processes such as very high-speed silicon and the 3-5 family of materials that includes gallium arsenide. This presentation provides information on the installation and setup of the Cascade Microtech Model 42 microwave probe station. Begin by first preparing a workstation site that will receive the probe station. Clear a staging area near the site for the equipment boxes and crate. Next, unpack the accessory boxes, staging the equipment for easy access. Then, unpack the crate. Upon opening the crate, remove and review the important messages sheet and the attached unpacking instructions. Proceed with the unpacking by removing the 4 foam packing corners first, then the 4 side packing panels. 2 people are required to safely move the station. Using the hand openings provided in the side packing, each person should reach in with one hand to lift on the base while using their other hand on the top plate to counteract any rotational force. Now continue the unpacking procedures by loosening the 2 front shipping bolts and allowing the bolt heads to rest on the table. Next, carefully lift the base front and remove the bolts and washers. Now, remove the 2 rear shipping bolts and washers. Then, remove the 2 shipping spacers by carefully lifting the top plate at the back side and taking them out. Next, remove the shipping blocks by gently lifting on the top plate front and taking them out, placing them in order to receive the turned-over top plate at a nearby workstation. Now, with 2 people, lift the top plate directly up from the base. Turn it over and carefully lower it onto the blocks. The next step is to remove the red tape from each micrometer head. Now remove the shipping spacer from each micrometer head. Turn the thimbles clockwise past the point of resistance. Then remove the slotted shipping spacers. Next, remove the center foam block after turning the 4 x-axis micrometer heads located on the sides counterclockwise to relieve the pressure on the center foam block. With the foam block removed, adjust the 4 micrometer head thimbles back to a mid-range setting. The next step is to reposition the top plate onto the base. Use 2 people to lift the top plate from the blocks. Turn it over and align the Z-axis micrometer heads left and right with the base holes. Then, carefully lower the top plate onto the base. Next, inflate the vibration isolation feed. Using the provided hand pump, inflate until the bottom membrane is flat. The next procedure is the installation of the microscope and its mount on the base. The M42 microwave probe station provides 5 different mounting positions for the microscope. To begin, snug tighten the microscope vertical column into one of the 5 threaded base holes. Next, slide the collar, the 2 U-shaped pieces, onto the vertical column and tighten the lock screw to clamp the collar in a position about 5 inches from the vertical column top. Lower the holder onto the collar, then insert the boom into the holder, making sure to align the groove with the holder's boom clamp. Tighten the holder knobs. Next, install and clamp the microscope rotatable arm to the boom. Insert the microscope rotatable arm pin into the boom and tighten the clamp. The next step is to prepare the microscope for installation. First, remove the cover plate from the microscope body. Next, remove the protective cover from the illuminator. Adjust the magnification knob to the 7 power setting. With the knob set, insert the illuminator into the microscope body and snug tighten the 2 mounting screws. The next step will be to mount the microscope body onto the boom arm. Verify that the vertical column clamp is tight and secure. Loosen the 2 arm lock levers, moving them away from interference. Now lower the microscope body into the rotatable arm. Engage and tighten the 2 arm lock levers. To complete the microscope installation procedure, insert the 2 eyepieces into the microscope body. The next phase of the setup procedure is the preparation of the grease plate and installation of the wafer stage. Remove the grease shield by pulling straight up. Next, clean the grease plate top surface with a clean lint-free towel. On the clean surface, squeeze about 1/2 inch of the supplied silicone grease. Use your fingertip to pick up and distribute the grease to approximately 10 other grease plate locations. Continue the process by using your finger to evenly distribute the grease over the entire grease plate surface. Upon completion, lower the grease plate shield back onto the grease plate, pressing it down firmly. The next step is to unpack the wafer stage and clean its foot with a clean lint-free towel. Then apply a thin coat of silicone grease to the foot contact surface. Carefully set the wafer stage onto the grease plate. Next, attach a vacuum source to the grease plate vacuum line, and then turn the vacuum on. Place a thin pliable material, such as mylar or latex, over the holes in the wafer stage chuck to create a vacuum between the wafer stage and the grease plate. To complete the grease plate preparation and the wafer stage installation, grasp the wafer stage body, apply downward pressure, and move the wafer stage around the grease plate. 10 or more wafer stage movements across the grease plate will be required to spread the grease uniformly. The silicone grease is correctly spread when the wafer stage moves smoothly without hesitation and the vacuum seal is complete. To verify that the vacuum seal is complete, check the flow meter. It is suggested that you practice moving the wafer stage before installing probes. Keep your hand low on the wafer stage. It is possible to tilt the wafer stage and damage a probe if pressure is applied near the top. The next procedure is to mount the probe arms and probe heads. Prior to mounting the arms, check the mounting surfaces for burrs or dirt. Next, position the arm on the riser and snug tighten the 3 screws that hold the arm to the riser. Next, prior to mounting the probes, be sure that the Z lever is up and the wafer stage is positioned to the front of the grease plate to provide clearance between the probes and the wafer stage. Remove the probes from the storage cabinet, grasping the probe head block by using a thumb and forefinger, pulling straight up. Next, position the probe over the arm and lower over the arm's locator pin. Then, snug tighten the 2 mounting screws. Before repositioning the wafer stage under the probes, visually verify that there's adequate clearance. The Z lever simultaneously raises and lowers the top plate and all probes assisting in repetitive probing. The Z lever is raised, lifting the probes from an already tested device. Check that the Z lever does not drop under its own weight. Adjust the Z lever friction adjustment set screw as required. There is risk of damaging microwave probes if the Z-lever is up when adjusting the Z-axis micrometer heads for contact to the device under test. With the probes already contacting the device, moving the Z-lever down can damage the probes. This completes the Cascade Microtech Model M42 Microwave Probe Station presentation. Consult the instruction manual for details not found in this presentation. The people at Cascade Microtech are dedicated to customer service, application support, and the continued development of tools which contribute to the advancement of high-frequency test and measurement. Their commitment to excellence and responsiveness to customer needs is unparalleled.